Hi, I'm going to solve the quiz 1 from week 4 that says like follows. A 2 kilogram object is attached to a string and placed horizontal, smooth surface. A horizontal force of 20 newtons is required to hold the object at rest when it's pulled zero point 0.2 meters from its equilibrium position, the origin of the x-axis. The object is now released from rest with an initial position of the same one, 0.2 meters, and it sequentially undergoes simple harmonic oscillation. We have to find first the force constant of the spring. For finding it, we know that the formula for the force in spring's oscillation is minus the constant times the x. Okay? We know the force and we know the x, but we are asked to find the constant, that it's this one. So if we take out the k, we will obtain that k will be equal to the force over x, that it's the distance displaced. If we substitute these, we obtain that 20 newtons over 0.2 meters will be equal to 100 newtons over meter. And this is the constant of force. Then we are asked to calculate the frequency of the oscillations. For calculating the frequency of the oscillations, we have first to obtain the angular velocity. And we know that this one is equal to over m, that it's the same as we say that this one it's equal to square root of the k over the mass. Now, if we substitute the values that we have already, we know that the constant is 100 newtons, and the mass it's 2 kilograms. So here we put 2 kilograms. And we know that the angular velocity it's equal to 15 radians over second. Okay? Once we know this value, we now can calculate the frequency with the formula that says that omega is equal to 2 pi times the frequency. And if we get the frequency out of the equation, we will obtain that the frequency is equal to omega over 2p. We know this one, so we only substitute this value here. We'll obtain 50 radians over second over 2 pi. And as we solve this, we will obtain that the frequency is equal to 1.13 hertz. Okay? This is the second part. The third part of the problem says that we have to calculate the maximum speed of the object, and where does this maximum speed occur? So we know that the formula for the maximum velocity it's equal to the amplitude times omega. And we know that the amplitude is the maximum position that the object can reach in the movement. So it will be 2.2 meters. So we will have 0.2 meters times the omega that here we obtained, that was here, 50 radians. So we multiply this by the square root of 50 radians over second. And we will obtain that the maximum velocity will be 1.41 meters over second. Okay? Once we know this value, we were also asked to provide where does the maximum speed occur. And by by knowing this, we have to see that when the string goes to point 0, the potential energy will push the object instantly, and in that point, in the point that it pushes, it's the point where more velocity is established. So he will be at x equals to 0. Okay? Now, we were asked to calculate the maximum acceleration and where does it occur. We know that for the maximum acceleration, we have the amplitude times omega squared. And it's the same as in this one, but here the square root get cancelled, so we obtain only times 50 radians over second. And by multiplying this, we will obtain that it's 10 meters over second square, the maximum acceleration. And where does it occur? It occurs at x when it's the value of the amplitude, that it's the highest position where the object can reach. Because when the object occurs to be in the side of the amplitude, it will be pulled and there would be an acceleration. And in this part, when the object is pressed towards the spring, it will be also an oscillation. So it's in the amplitude and in the amplitude over here. Okay? After this, we are asked to calculate the total energy of the oscillation system. And we know that the formula for the energy, it's equal to half times the constant times the amplitude squared. We know the K, we know the amplitude, so we only have to substitute the K. It's 100 newtons over mass times the amplitude. Okay? Once we know this, we only solve this one and we will obtain that the energy is 2 joules. Okay? Now, we are asked to find the speed and the acceleration of the object when its position is equal to 1/3 of the maximum value. So we know that when the amplitude is 1/3 of the normal amplitude, that is this one, we will have to calculate the velocity. We can use this equation of energy, that is the same as we use here, but we are adding here another part of an equation that it's equivalent. By having this equation, we can get out of the equation the velocity, because we know all these terms and we are only missing the velocity. So here, if we get out of the equation the magnitude of the velocity will be the square root of the constant over the mass times the amplitude squared minus x, and this will be equal, if we substitute the values we know, to 100, that it's the constant, the mass, the amplitude square, and here will be x, when x is equal to this. So here we'll substitute the x towards 0.2, that it's the amplitude, over 3, that is 3 times, okay? It's this one is this one. Once we solve this, we will obtain that the velocity is equal to 1.33 meters over second. And we're also asked to calculate the acceleration of the object at the same position. So we know that, I'm going to write it here, that the acceleration, it's equal to minus the amplitude omega squared cosine of omega t plus b, and this is equal to also this one. By knowing this, we only can see that the acceleration will be equal to this, and we know both values, so we can write here that the acceleration in magnitude, it's equal to omega squared, that was the square root of 50, times x. And this, as it's square, we cancel the square root times the same x that we are asked, that is 1/3 of the original position. And this, as solved, we obtain that it's 3.33 meters over second square. And this is how you solve this quiz.